Good afternoon, Dr. Pearce here again from the Cotswold School, just going through question 3 of the 2023 Paper 1 GCSE AQA Chemistry. So this one's questions about making a soluble salt, and you want to make pure dry crystals of zinc chloride from zinc carbonate and a dilute acid. Now, I've had a number of people answer this question, and one of the things is they don't name that acid. You have to name that acid. You're trying to make zinc chloride. So we know zinc carbonate is going to be the source of the zinc, but we've got to think, which acid are we going to use? So what do we need to use? We're going to have to use hydrochloric acid. And that has the formula HCl. Now, as someone who's a chemist, I'd quite like to say, that's HCl by the way, even though it doesn't look like it at the moment. As someone who's a chemist, I would like to sort of be a little bit more expert and actually go, okay, we've got zinc chloride. Zinc chloride has the formula ZnCl2. So we know that ZnCO3, which is a solid, plus our 2HCl, which is an aqueous solution, will make our ZnCl2, probably as an aqueous solution, plus some water, which is a liquid, and we'll have some CO2 coming off that as well, which is of course a gas. So that just sort of focuses on what we're going to be using. So our first step is to say, using a measuring cylinder, measure 50 centimeters cubed of hydrochloric acid, and you might want to say 1 molar hydrochloric acid, depending on how detailed you want to be, and pour this into a suitable sized beaker. Oh, apologies, it's this writing pad. I'd use maybe a 100 centimetre cube beaker or a slightly bigger one. Now, our second one is to add spatulas of zinc carbonate and we want to do this until no more dissolves. What we want is we want an excess of it, and the reason why we use an excess of this is so that there's no more hydrochloric acid lying around. So we add spatulas of zinc carbonate until no more reacts. Now, it might be that you actually want to heat this up to make sure that all of it has reacted and it reacts more quickly. But what we're going to do in this case, because it's a carbonate, they usually react relatively quickly anyway, and stir to ensure all has reacted. Okay, so we now have a zinc carbonate reacting with hydrochloric acid, so we'll have a zinc chloride solution. So we've got our solution, but what we want is we want pure dry crystals. So the next thing we need to do is we need to filter out the zinc carbonate. So using a filter funnel, we are going to pour contents of beaker through the funnel into a conical flask. Now, the reason why I use a conical flask is just because it holds the funnel, and also it's a little bit safer. You're less likely to splash anything or get contaminated. So you pour the contents of the beaker through funnel into a conical flask. So what we now have is a solution of zinc chloride. We've got rid of the solid zinc carbonate because it's come out through the filter. And what I'm going to do is pour the conical flask contents into an evaporating basin. And what we're going to do is we're going to heat contents of evaporating basin . Apologies, my pad is a bit strange sometimes. I'm going to pour heat the contents of the evaporating basin, and when dry, we're going to take out the crystals. So that should be all of our marks for that one. Name 2 other substances that can be reacted with dilute acid to make zinc chloride. So we've already had zinc carbonate. We also remember zinc also reacts, and if I add zinc to hydrochloric acid, it's going to make zinc chloride, and it's going to make a bit of hydrogen. We can also have zinc oxide, and that will make zinc chloride and water. We can also have zinc hydroxide, which again will make zinc chloride and water. So lots of different ways of making the same thing, but it's really important when you do these, you're very specific about how much you're putting in there, and make sure that you are specific about which acid you're using, etc. So that's the end of question 3.